Okay, so now we'll move on to our next practical moment of the day. We will have Álvaro de Pascual Colar, who's gonna tell us about a very interesting tutorial he developed, and is gonna do a little bit of a presentation about it, maybe some demonstration. So this is related to one of the tutorials you are able to find in the page dedicated to this webinar. Hopefully you had time to look at it. If not, you will get a little glimpse now, and maybe later on you will practice. So Álvaro, whenever you want, the floor is yours.
Hi, good morning to everyone from Spain. Well, good afternoon for the people in Asia. Well, my name is Álvaro Pascual. I'm gonna share my screen. My name is Álvaro Pascual. I work in Login Ocean Nuclear Systems. And this session and this speaker will explain a little bit about the Jupyter notebooks we have proposed as examples for this webinar. In these Jupyter notebooks, we are doing a fast analysis of El Niño Schroeder oscillation, also known as ENSO. And with these Jupyter notebooks, we will use Python code to analyze the ocean fields. Is this okay? Well, here you have just a short view of what are you going to find in this section in the Jupyter notebooks. Well, we will access the Jupyter notebooks through the web page of the course. I will explain this later, and we will work in the framework of Jupyter Hub. Yeah, that is a platform where you can code your own material and you can run cells, etc. It's very important for any user to know that the Jupyter Hub, the Jupyter code has to, the notebooks must be downloaded and copied to your home directory. So we will see how to do it right now. And because this is the first step, and it's a mandatory step. If you don't copy the material to your directory, you won't be able to run the material. Well, let's go to the material. Clicking here. Andrea, can you see my web browser?
Yes.
Thank you. Sorry, it was just to be sure. Well, this is the web page of the course, as you can see, and you can access the Jupyter notebooks by clicking in this link here, and you will access this web page where you can find very different options. Here, there are some options to download the materials and some documentation to download the material and run the material in your own computer. It's very interesting because you can create an environment, a Python environment in your own computer and start to work with Copernicus data in your own computer. And well, as I said before, one condition to enter in the Jupyter Hub is to be registered in Copernicus Marine Service. I think if you are watching this tutorial, this video, you will have to be already registered, but if not, you can click here and go to register in the Copernicus Marine Service. And after that, here is the link to access the contents. And by accessing the contents, you can see there is a web page where you are asked for your credential of Copernicus Marine. You enter your own credentials here, and you can log into the Jupyter Hub platform. It can take a few seconds, and well, this is what we have. A fast explanation could be that there is just a file browser here, and in the left in the right side of the window, you will have the workspace, right? So as I said before, the first thing you need to do is to copy, just to access the material, is to copy the contents to your home directory. You will see that you are here in your home directory, and probably you will have different directories depending on what have you done in this context, in your directory. So to copy the materials to your directory, you will have to open a terminal, and you will have to write copy from Jupyter Notebooks Training Asia. So excuse me, there is something here. So with this is a Linux terminal. So this is a Linux command where we are asking to the computer to copy with recursive mode this directory to the directory where we are already now. So we can enter, and you will see. Okay. You will see that in your home directory appear this directory. You can close this window now. You can close this window, and you will see that directory. That is the directory where you will find all the contents and the materials of Jupyter Notebooks. I already had, if you excuse me, I already had this example already run, so I will start working with this now. But in your case, you will start to entering in this directory and opening this file. But in my case, I will go to the run directory, and I will open this file, which is a notebook, a Jupyter Notebook. I don't know if you are familiar with Jupyter Notebooks. Jupyter Notebooks is a format of code where you can mix documentation like this. You can see there is HTML documentation, and also there is cells of code. These cells of code can be or must be run by clicking on the run button up here. You can see, and there will appear here a number that means the ID of the run you have done. For example, you can click here and you will see that the cell is running, and now you have the ID of this run. And well, I don't want to spend much time on this, but as I said before, we are doing in this tutorial, we are presenting an analysis of the Niño southern oscillation. As you probably know, the El Niño southern oscillation is a large-scale warming event in the equatorial Pacific Ocean, and this is the switching between two main phases. Let's say that there is a neutral phase, that is this kind of phase where the trade winds blows from east to west, so they drag, they produce a transport of surface waters towards the west. That means that in the east side of the equatorial Pacific, there is some upwelling conditions that produce a cooling of these waters, and in the west side of the equatorial Pacific, near New Guinea and Philippines, there is a warming of the waters, right? So this situation is not stable, it's not static, this is stable, has some variability from the situations that we call El Niño and La Niña. In case of El Niño situation, we have a weekend of the trade winds. That means that this mass of water, cannot be maintained in the west side of the ocean. So this mass of water is transported towards the east, producing a warming of the east side of the equatorial Pacific, and producing also a cooling of the east side near New Guinea and etc. And La Niña situation is almost the opposite, right? There is a strength of the trade winds. That means that leads to a bigger transport of warm water towards the west and increasing the upwelling in the east side of the equatorial Pacific, right? And well, what we are going to, in this tutorial, we analyze these situations and we do it programming in Python. Here, this cells program in Python. You can go over the video if you want to have a clear explanation of every cell. You can go over the video. So we spend time explaining every line in every cell. Now, it's just to say that you will have to click on the run button of every cell and see the results. And well, in this tutorial, we work with two different Copernicus products. We use the global reanalysis, the physical global reanalysis, because we are going to do an analysis of sea surface temperature. And also we use an OMI from Copernicus, ocean monitoring indicator from developed and produced in Copernicus that is actually El Niño index. Here you have the result of this OMI. It's just an index that gives us information about the situation of this oscillation. The positive values of this index are associated to the El Niño situation, and negative values of this index are associated to the situation of La Niña, right? Well, along this tutorial, we learn how to get the data of this OMI and how to plot this OMI, and we discovered that as usually occurs with Copernicus OMIs, they are multi-product. They are multi-product, so they are produced as ensemble systems. So we do not only have the values of the product, we also have information about the uncertainties of the product, because we have an ensemble mean and the spread of the ensemble mean. We learn how to plot the ensemble mean and also the spread of the ensemble mean, and we go further by plotting not only this, but also plotting the annual means in bars, right? So we start to work with this index in annual means from now on. With this plot, we learn that, for example, the year 1997 and 2015 was years of very intense activity of El Niño situation. And for example, the year 1999 was a year dominated by La Niña situation, right? And after that, we go to work to see what happened in the ocean in these specific years. And to do that, we download data from the reanalysis, physical global reanalysis from Copernicus. And this we go to download this data using the Copernicus Marine Client. This is a very novelty in Copernicus services. It's a way to download data from Copernicus just using Python commands. So just, I don't want to spend much time on this, but we code these lines that we use the function subset, a very interesting function from Copernicus Marine Client, a function that enabled the downloading of data very fast, really fast, and very simple. You just have to know how to give the configuration of this function that maybe seems to be a little bit complex, but at the end is not as complex as it could seem, because as Leila said, you can get the information of this configuration from my ocean viewer. You also can go over the Copernicus data store web page, and there is a little button when you are trying to download a group of data. You define the group of data, the data set you want to download, and there is a button that the button automate. So you get all the information you need to fulfill these subset functions. So I think it's a very interesting part of this course. I really recommend to anyone who is interested in downloading data from Copernicus to go over this part and understand and see that it works really, really fine. And well, after downloading the data, we start to plot maps of anomalies. And firstly, we plot maps of anomalies just for specific years. For example, here we go over the years 1999 and 2015. And we code the Python lines needed, and we code some functions to plot maps of anomalies like this. So we can see the anomalies of sea surface temperature in Asia, also in Asia, associated to years with intense activity of El Niño and La Niña pattern. But we see here, we will discuss in the video that these results are not as good as we would like. And we go into the next section where we code how to plot El Niño and La Niña patterns. To do that, we use the El Niño index we plotted before at the beginning. We use this El Niño index, and we make a mean of the years that are dominated by El Niño, and we make a mean of the years dominated by La Niña, and we plot the anomalies of these two these two groups, and we obtain, oops, this section is not run well. It's removed. Well, and we plot yep, we can go over this. Let's see my. And well, as you can see, we in the tutorial we plot the specific patterns associated to the positive El Niño index and to the negative El Niño index. That actually the negative El Niño is actually La Niña pattern. Well, I hope you enjoy the tutorial. You learn things and you find interesting information here. I think the downloading procedure is very interesting and very new in Copernicus services.
Thank you, Alvaro. Yeah, that's very interesting, and I hope that sparkled a little interest in our participants to go and explore the tutorial fully. We do have a few questions for you. I don't know if participants try to do the exercise themselves, because some of them were having an issue, a technical issue. So first one, I'm just trying to, so here we go. And the first question is when or why the OpenDAP connection through the Jupyter Notebook is deprecated. Are there other options if we want to manipulate heavy data?
Yeah, well, why the OpenDAP connection is deprecated? I cannot answer this question because, well, it's the politic of Copernicus services. But yeah, the other option to manipulate heavy data is the option you will find in the tutorial. Is they use the Copernicus Marine Client. Is very fast. Is for me, I think. I think I didn't expect that you can download very fast the data, and actually it works fine, and actually well, it's very simple. Maybe in the beginning may seem a little bit complex, but once you have the first configuration of the subset function, you have you are open a window to download a lot of data in very fast mode and very simple manipulating the differences. I recommend to this user to see the section in the tutorial about downloading data, because I think that's the way to do it.
Okay. Thank you. And then now there's someone who indeed found an issue. I keep getting this error when I try to open up again with open up. NetCDF, malformed, or inaccessible. I think it's the same problem. What does it mean? Or does it say something to you in particular, this error?
Well, is it malformed or inaccessible? Yep. This could be, I don't know in what section this disappear, but maybe the problem is that the NetCDF is not in the system. I don't know if the user has already downloaded the data, or maybe I will recommend that. Well, it seems there is.
Yeah.
Let me find. I will share my screen for a second.
Sure, you can.
Here. Well, I think if you find some problems, sometimes this kind of problems can be solved by restarting the kernel of the system. You can click here in kernel, and you can click here in restart kernel and clear all outputs.
I can't see your screen, Alvaro. I don't think you're sharing.
Oh.
I can't see your screen.
Sorry.
No worries.
Now yes, right?
Yes, now it's good.
Well, so I said sometimes these kind of errors can be solved just by restarting the kernel. So you can click here in kernel, restart the kernel and clear all outputs and restart. Well, this will clear all outputs of the system, so you will lose all the figures you could created before. But well, it's not difficult to go from the beginning and running the cells and etc. Right? Yes, you can go and click on the cells, etc.
Cool, thank you. The next question is more general. Do you have any link or experts that can chat regarding Python queries? Or if you have any questions related to our data and how to access it via using Python, you can contact our user support. But we also have a few articles already dedicated to this topic in the Help Center. Yesterday we had Cedric who showed you how to access the Help Center, and you will find a few articles already dedicated to Python and maybe GIS as well, QGIS. Yeah, in our previous workshops you will also find longer tutorials where you have deeper explanations on how to access it. And in basically every Jupyter Notebook tutorial, you will find information on this. But if you have a more specific question, don't hesitate to contact the user support.
In the tutorial, in the sections, I think in the section of downloading data, I provide some links to the Copernicus Help Center.
Perfect.
Your questions about Python are related with the creation of environments of Python or environments and use Copernicus Marine client. I think in those links to the Copernicus Help Center, you will find also help and also ways to contact people that maybe they will help you.
Yes. And another question about your exercise. Do you have an example of analysis to analyze the correlation between ENSO and the wave height together? I don't know if it was something.
Well, it would be very interesting, actually. It would be very, very interesting exercise. I don't know. Actually, one of in the previous versions of this tutorial, we evaluated the option to include the analysis of correlation in specific points in the map. But at the end, we thought it was quite difficult for users. So we decide to remove it. I don't know if there is any way I could provide these cells to the users.
Would it be an advanced level, you think? More like an advanced exercise?
Yeah, it would be some kind of, it would be some way to provide extra material for people with, for example, for people who is interested in correlation analysis, we could provide the functions because they are already code. But well, I don't know if we have a way to
make it available.
Make it available.
I recommend the user, if you're really interested in that, you can contact the user support and we will make sure it gets available to them. I mean, if Alvaro, you're happy to share it, why not? I mean, we can definitely do the link between. So whomever posted this question, if you're available in this study, and Alvaro is happy to share it with you, just get in touch with the user support, the Copernicus Marine Service support, and we will make the link between you guys.
Okay.
Thanks for that, Alvaro. It's very nice.
No, it's something that is already done. It was actually a pity because we had all that material and we thought, well, this is too much for just authors, and we decided to remove from the material. So I think it's good if we can share this code and it's at the end it's useful. It would be great.
Yeah, no, that's definitely. It's basically a never-ending exercise, right? You can always add something.
Yeah, actually, this is the opening of a door where you start to analyze the El Niño, but this is a very actually it's very simple exercise. You can spend all your life analyzing the El Niño, right? So there is people that works in that for all his life.
Exactly. I noticed, so to respond to a previous question on the OpenDAP access, just to let you know or remind you, yesterday we had Cédric Jourdain. He told you about how we are transitioning data, the marine data stories in a transition period. And so some of the data sets might not be available at the moment because they are being transferred to another kind of platform. So some of the data sets might not be available for the moment, but at the end of March, this transition period will be done and you will be able to access all the data sets again. It might be related to that, the OpenDAP problem you were just mentioning before. I think for the Jupyter notebooks for now, we don't have any other questions. Yeah, I think we are good to continue to our next speaker. Thank you very much, Alvaro.
Thank you very much.
So yes, take your time to look at these tutorials and hopefully you will enjoy it.